I always tell my students, whenever you look at a coral reef, when you snorkel, what you look at are nice, colorful, weird things, slimy objects, and from what I see is it's chemical warfare that's going on, right? Because you have a surface area of the coral reef which is limited, and then you have so many organisms trying to survive on that tiny space. And so at the end of the day, it's the organism who produces the most potent, most bioactive molecules, whether it's whatever, anti-this, antimicrobial, anti-whatever. They're the ones who will survive and populate the coral reef. And so it's, again, it's that. So in addition to the biological diversity of the organisms that's there, the other thing to look into is the chemical biodiversity, which comes about as a result of the competition that's going on the coral reef.
So pag nagsasnorkeling ka pala, lalim ng iniisip mo, no? Pare, pag ako nagsasnorkel lang ako, uy, may Nemo, oh. O kaya, uy, may nakaiwan ng trunks dyan sa tubig. Today's guest is Dr. Aaron Villaraza. He is a chemist from the University of the Philippines and is regarded as an outstanding young scientist with a PhD in chemistry from the University of Manchester. His research focuses on medicinal and bioinorganic chemistry, particularly in developing metal-based compounds for medical and diagnostic applications. He is also studying the bioactive natural products from marine and venom sources for anti-cancer treatments. In this episode, we discuss the current state of science in the Philippines, as well as the opportunities and gaps for young scientists. Join us and welcome to the Jeepney Show.
Hop on! The Mad Jeepney!
And we're on. Doc Aaron, good to see you again.
Yes, and I'm glad to be on this show.
No, thank you. And thanks for doing it the second time around. For those not familiar, we actually had some tech difficulties the first time we tried to shoot, but we have Doc Aaron again back. Doc Aaron, UP professor, outstanding young scientist of the Philippines, and PhD in chemistry.
Correct, yes, that's right.
From the University of Manchester, UK. And we're here to talk about science. But before we talk about science, maybe what's up? How's life lately? What you've been up to with your research and maybe with your teaching career at the UP?
Well, one of the reasons why I was interested in, joining this interview is because, I thought that it would be a good opportunity to explain what happens or what exactly an academic career is all about, right? So I guess because whenever there's let's say class cancellation because there's a transport strike or maybe a typhoon and then classes are suspended, so many people message me and say, oh, lucky you don't have any work, classes are suspended. And I in my mind, it shows that people are actually unaware of what an academic does. I guess, where this comes from is really because the normal experience of the student is just to see the professor standing there in front of the blackboard and teaching, and they probably think that, okay, this is probably all that the professor does. But actually, academic life is so much more. Teaching is just one part of it, and it's actually a small part of it. Right, so normally, beyond the teaching, which itself is already a full-time job, in academia, the expectation is that you are also engaged in research, in admin work, and also in extension work, right? So,
what is extension work?
Well, let's say, for example, let's say your research can have a benefit to, I don't know, some sector in society. So then you start with projects and you engage with that sector of society. So, for example,
More of like the application or applied
Yes.
theory. Okay.
like for instance, I have a friend who is teaches environmental engineering in UP, who would actually appear on television every so often because of his research on waste disposal. So he's an expert on waste disposal, and one of the things that he had discovered was how some people in the landfills will collect these, wires, and since they're after the copper in the wires, they would just burn the wires so that the coating, the casing could easily come off, and then they then collect the copper. But the thing is that the insulation material that's used to cover these copper wires, when you burn it, produces all of these carcinogens. And so there were many cases of precisely people in that local community who were coming down with all sorts of diseases. So he and the team, they started to then engage with the community, try to educate them and tell them that, okay, yes, you do need the copper, but burning them is the unsafe way of collecting that copper, right? So so that's an example of extension work.
Okay. And when you say academe is teaching, research, admin, and extension, would you say that this is how, of course, this is how it should be, but would you say that this is how it is currently in the Philippines?
All right. I guess this depends on which institution you look at, right? In 2009, or was it 2008? Because I'm from the University of the Philippines. So the University of the Philippines basically redefined itself, or rather clarified what it is, and said that it is a research university, right? Because there's a difference between what people refer to when they, speak of a college versus what a research university is all about, right? So the difference is that usually people go to college because they want to acquire certain skills in order for them to be able to get a job later on, right? So
more practical.
More practical. I mean, for example, no one can really learn, I don't know, maybe something like accounting on their own, right? Whatever. So you go to a university, you go to a college, which basically gives accounting courses, and for reasons of the regulations imposed by the PRC, then you have to study, get a degree, and then you then have to take national qualifying exams, right? So these kinds of teaching colleges, they compete on that level, right? So how many graduates can we produce in our degree programs? How many of them become top-notchers in whatever, licensure exams, so on and so forth. The university does that and more, okay? Because really, historically, what the university was all about is about, knowledge generation, certainly knowledge dissemination, which takes the place in the form of classes and teaching, but knowledge creation is very much part of the activity of a university, which means research.
And talking about research, what have you been researching lately?
All right. Okay. Well, for perhaps the last 15 years of my life, I've been working on peptide chemistry in the context of venom science. Now, the reason why I got into this was, prior to coming back to the Philippines and getting this position in UP, when I was still in the UK, I was working on a very different field. I was working on lanthanide chemistry, producing inorganic complexes which could be used in the context of disease diagnosis. And in fact, after the University of Manchester, when I moved to the United States National Institutes of Health, I worked specifically in the National Cancer Institute and the radiation oncology branch to develop the complexes which I had worked on in the UK and to apply them to specific cancer states. In fact, for those years, I was working specifically on breast cancer because breast cancer is one of these, it's a mutilating cancer. Best if it's diagnosed early, and so when I came back to the Philippines, I still wanted to continue along the line of medicinal chemistry, but it's what I realized was, well, the level of resources, from you comparing the UK and the United States and the Philippines, the level of resources was not the same. What did we in the Philippines have as a readily available, accessible resource? It was coastal waters. And what was unique about the coastal waters and the coral reefs, that we have this tremendous biodiversity of marine snails, which produce all of these fascinating venoms, which are full of bioactive peptides, which are used by the snails in their own hunting activities.
When you say something is a bioactive peptide, what exactly does that mean for the non-scientist?
Oh, all right. Okay. Okay. Usually, medicinal chemistry. Oh no, let's take a step back. Nature is the best chemist. Okay, and when you try to develop new drugs, one approach is to do it from nothing. I mean, from first principles. You can try to these days, many people ask a computer to design drugs for them, right? Design new molecules specific for whatever targets, So that's one way of doing it. But the way we do it is by looking at nature, because many of these compounds, which you find in nature, have evolved to have all sorts of interesting bioactivities, and which have been proven to be evolutionarily robust, right? So, in other words, nature has fine-tuned the activities of these molecules over the centuries. No? So, and this is the reason why, for the longest time, most of the medicines were always found in nature. They were found in certain plants, they were found in certain animals, and really where the leads are, where you discover the leads is when you observe what is happening in nature. How do certain organisms use their chemical biodiversity, and see if the same applications can be applicable in the human context.
So what you're researching, or what you've been researching for the longest time is, venoms, the medicinal properties of venoms in the natural setting, and maybe trying to find out which ones are useful for the human being.
Correct, yes.
Okay.
For example, I mean, I'm not the pioneer in this, right? So the pioneer really in this field is a Filipino scientist. Well, they were a dynamic duo. So Professor Baldomero Oliveira, who is a scientist, professor in the University of Utah. And the other is Dr. Lourdes Cruz, who is an emeritus professor of the Marine Science Institute of UP Diliman, and is one of the country's national scientists. So way back in the 60s or 70s, they had first looked into these marine snails in the Philippines, which would produce these venoms, which the marine snails would use in hunting activities. So it's really a fascinating thing to watch. You have the snails would hide underneath the sand, and then when a fish comes by, they would sting the fish, and then once the fish can't move, then they would come out of the sand and swallow the fish whole. So, okay, so
paano kaya nila naisip na i-research yun, no?
Okay, so in the context of medicinal chemistry. All right, because therefore, what the biological observation tells you is that, the venom of the snail paralyzes the fish. The fish is a vertebrate. Therefore, since human beings are also vertebrates, it might work on us as well.
In terms of paralyzing
Yes.
human beings. So
Now,
were they trying to find out a drug that could temporarily paralyze or permanently paralyze? Or was it more of trying to find out what these venoms can do to other beings?
Well, okay. I guess where the gap then was coming up with pain relievers, right? So why is it a gap? I mean, historically, pain relievers have always been, the ones which are used in the clinical setting really for really severe chronic pain, usually are drugs which are based on opioids, right? So codeine, these kinds of drugs. But, eventually what happens with these drugs is that the patient develops, desensitization, right? The patient eventually develops like,
Addiction even,
addiction,
right?
yes. It
Di
can
ba may
become
opioid epidemic sa US now,
correct,
di ba?
yes. Precisely because every time you administer an opioid, to maintain the same level of pain relief, you will have to watch very carefully, and you may have to increase the dosage, every so often just to get the same level of pain relief. So, okay, from my point of view, I was when I got involved in all of this, I told myself, okay, cancer drugs, anti-cancer drugs. I mean, there are so many people looking at anti-cancer drugs, right? You have a whole National Cancer Institute in the United States looking at anti-cancer drugs. And what about the labs in Japan? What about the labs in Europe, the labs in Australia? There's so many looking at anti-cancer drugs. But how many people are looking at drugs to manage the patient? Because the reality is, cancer patients are in pain, right? So, or doesn't have to be cancer. You can have many other disease states and which cause pain. And I think the problem of pain is something which has been overlooked to some extent. And here was the Philippines with its marine biodiversity offering a possible solution. So I thought, okay, this is something worth looking into.
Okay, interesting. And what are the findings so far?
Well,
Or maybe indicative findings.
well, okay. The one of the first molecules which Baldomero Oliveira and Lourdes Cruz looked at is already, in fact, FDA approved. It's called ziconotide, Prialt, the primary alternative to morphine, because it's like 100 times more powerful than morphine. But the best thing is that the patient doesn't get used to it. So every dosage is as potent as the previous one.
Nice. And this is from sea snails.
Yes.
Okay. And is that made possible through the research done by these two scientists that you
Yes,
mentioned?
they were the
Okay.
ones who discovered it. And, and
Ano
that's
pala
why...
process niyan? Like, if they discovered it, of course, now it's scientifically proven. Bebenta ba nila yan sa big pharma or small pharma?
Yeah, well, right
How
now
exactly does it
it's a
work?
pharma company who owns it. Right?
Okay.
So basically, where the universities come in is first to do what is generally referred to as the bench science, which means that you establish first principles, which means that for decades, Oliveira and Cruz and their teams, they would go out into the field, they would collect different snails and then bring them back to the labs and then extract their venoms and venoms are very complex chemical mixtures, right? There's so many components inside the venom and it's really like finding a needle in a haystack. Amidst this complex mixture, you have to pick out which component is the one which provides the highest bioactivity. And if a molecule is very bioactive, then the organism actually has no reason to produce it in large amounts. Right? So,
Kasi effective na siya at small doses.
Exactly.
So there's no natural need to produce more.
Correct.
That's what you're saying. Yeah.
right? So like the snail will say, why do I have to expend all of this chemical effort to make so much of this compound when actually only a little of it is really
Already
needed?
works, yeah.
Yes.
Okay. And at the moment, it's already proven. And any other research related to that at the moment which you're looking at?
Well, okay. I mean, with respect to the snails, that's an ongoing thing. I mean, I think that it will continue to give birth to new projects, new grad students, new projects. So
Ano pala, kumbaga, if you want an alternate to morphine, you can request for that, what do you call it?
pre-alt.
Prialt as as the alternate when you're in
Yes.
pain.
Correct.
Interesting.
In fact, it was approved specifically for the treatment of, of chronic intractable pain. The only difficult thing with this drug at the moment is that the only mode of administration is via epidural injection, which, patients,
What's epidural, sorry?
you inject straight into the spine.
Oh.
You lie down in a fetal position and then someone comes with this big syringe and then
So hindi siya yung sa balikat lang or sa puwet lang.
it
ano
has
siya?
to go
Sa
straight
spine.
into the spine. Okay, and the reason for that is because why not just introduce it like IV, right? Or as a pill that you can swallow. So the thing is that because these molecules are alien, it comes from a snail, right? A marine snail. Then if it enters into your bloodstream, then your own immune system will recognize it as something which is, like this is an alien thing. And so your own immune system will go after it and destroy it. And your own immune system might destroy it before it has a chance to do what it was intended to do. Right? So if you want it to do exactly what you want it to do, then you just inject it straight into the spine.
So that the homologation of the properties and the chemicals or the venom is well absorbed or
Yes. Right? Because
not seen as foreign by the body.
Well, because remember, the biological observation was that it paralyzes. Right? And so precisely by directing it straight into the spine, all of these nerve signals, which precisely are what transmit the sensation of pain, you block all of that already.
Okay. Interesting. And wow. That's a lot. That's quite a lot to take in. But in terms of that sea snail, is it only found in the Philippines or is there an industry already of harvesting these snails just for the sake of getting their venom to create this drug?
Well, okay. For the first question, are we the only ones with these snails? No. Right? So Great Barrier Reef in Australia, they seem to have some of these snails, Indonesia, Thailand. But, where the greatest degree of marine snail biodiversity, it's in the Philippines, right? And this is something precisely which had been established, I think maybe around 10 or 20 years ago, that really the Philippines is the marine biodiversity hotspot for marine shorefish, right? So, and in fact, it had been pointed out that specifically the Verde Island Passage, so that area of southern Batangas, Marinduque, all of that, so Mindoro rather, so all of that is where you have the highest biodiversity in the world of marine shorefish. And which is why it's an area that should be protected by the government. Because who knows? This is where precisely you could find all of the potential new drugs. And I always tell my students, whenever you look at a coral reef, it's summer now. People are going to the beach. They go snorkeling, and when you snorkel, what you look at are nice, colorful, weird things, slimy objects, and but from what I see is it's chemical warfare that's going on, right? Because you have a surface area of the coral reef, which is limited, and then you have so many organisms trying to survive on that tiny space. And so, at the end of the day, it's the organism who produces the most potent, most bioactive molecules, whether it's antimicrobial, anti-whatever, they're the ones who will survive and populate the coral reef. And so it's it's that. So in addition to the biological diversity of the organisms that's there, the other thing to look into is the chemical biodiversity, which comes about as a result of the competition that's going on the coral reef.
So pag nagsasnorkeling ka pala, lalim ng iniisip mo, no? Pare, pag ako nagsasnorkel lang ako, uy, may Nemo, oh. O kaya, may nakaiwan ng trunks dyan sa tubig. O kaya, ano pa ba? Grabe. So, now when I snorkel, I will think about, anong chemical kaya yung Meron dito pati. Anong organism kaya yung pinakamatibay dito, no?
Right? And it's a resource which is readily available to the Philippines, right? It's a competitive advantage. It's something that we have which other countries don't have.
But part of me also feels like, sometimes it's better that we don't discover these things because if it's actually a solution, it becomes lucrative, and then doesn't it put all these marine biodiverse areas at risk?
Well, this
at
is
some
the
point?
reason why government now has to come in and to ensure that these environments are protected.
Yeah, and then that there's ethical frameworks to and policies to protect it and to cultivate
Right.
both the science side, but still protect the species.
And in fact, where the science really comes in is that, okay, after the biological observation is made, which is that, okay, these compounds, they have all of these interesting medicinal properties. The challenge now is how can they be produced under laboratory conditions, right? Because once you establish how these compounds, how these molecules can be made under laboratory conditions,
Safe
then
na.
you don't have to bother the coral reef anymore.
That's true.
Right?
That's true.
So, and that's something actually which I had been trying and I'm still doing, which, because after years of doing natural products chemistry, joining teams and collecting these things from nature, at one point I said, okay, yes, we may be discovering new molecules, but really the next step is precisely to work on their total synthesis. How can we make them under laboratory conditions? Because if we do a complete pharmacological analysis, study assessment of these compounds, we're going to need lots of them. And if what does this mean? If we need lots of them, does this mean we have to keep diving again and collecting more? You're going to cause an ecological disaster, right? So therefore, once we know how the molecule looks like, then this is when the real synthetic chemistry comes in, and we then have to ask the question of, okay, how can we make this under laboratory conditions? And thankfully we've managed to establish the syntheses of several of these compounds, and you can find them all on Google Scholar. Just look for my name. So.
Okay. Well, we talk about a lot of the potential for the Philippines when it comes to research and all these potential solutions in the medical field just by our marine biodiversity. Would you say that the Philippines is still maybe underinvesting in the science field?
Oh, certainly, yes. And on the levels of both government and private, right? So, because there is only so much that the government can, first of all, the government has to be able to provide the regulations, provide the seed funding, provide, just to get the ball rolling, right? But then to eventually take it to market, this is where private money now has to come in. And it's really going to have to be that kind of effort, because, okay, the scientists themselves are busy doing the science, right? So they are busy in the labs, they're busy in the field, they're busy whatever. So they don't have the bandwidth, or only a few do have the bandwidth, thankfully. But, the majority of scientists just want to focus on doing the science.
And they're scientists, they're not managers, they're not
exactly
policymakers.
Yes,
they're
where they
not-
excel, what they have been trained in, and where they excel is just in doing the sciences.
And if you had it your way, what would you change in terms of the research policies that the government provides?
Okay. I think the biggest challenge with with the whole Philippine scientific endeavor at the moment is really the question of sustainability, right? So, unfortunately, the approval process from the submission of the proposal to getting the funding agency to finally approve it and to disburse the funds, that takes a lot of time. So currently, with the way things are being run, with the bureaucracy, you submit a proposal to a government funding agency. with the expectation that if approved, you will receive the funding at the earliest 2 years later.
Oh, so, the research topic could be, already, what, maybe uninteresting by that time.
Yes, right. In fact, I had a friend who,
Or
okay,
irrelevant, maybe even.
well, okay. More practical things like this colleague in the university, he submitted the proposal, and then part of the line item budget was to purchase computers. But computers are like hot items. By the time he received the approval for the funding, the prices of the computers had changed. So he had to completely revise the budget again,
and then wait for another 2 years.
wait another round of approvals,
Yeah.
right? Because 2 years is just too long.
And what's taking so long?
Bureaucracy.
Okay. Okay.
So there has to be a way to somehow, I don't know, speed up the process. I mean, for comparison, okay, so I'm also a member of the Royal Society of Chemistry of the UK, and as a member of the Royal Society, I'm able to apply for funding from the UK. And for instance, for one of the RSC grants, I submitted the application. Deadline was on December. I was notified that all my documents were complete by January, and then I was notified of project approval by March, and by April I had the money. Less than
So,
6 months.
Yeah, 5 months end to end.
Yes.
Okay.
Right? So versus local application research grant takes 2 years, right?
What are they seeing that we're not seeing in terms of why they're investing in science, or why are they making it so easy for science to apply for these grants?
I think it's just that these countries who have had a long history of how of investing in science sees that it's worth throwing money at 1,000 projects for only one to succeed, right? That's a risk that I think the Philippines is not ready to take. Right, so right now it's like the local funding agencies. They want you to promise so many deliverables, and and I tell myself, but again, this is basic science. It's hard to guarantee that we can deliver these things. I mean, if what we're doing is truly cutting edge research, no one really knows what's going to come out at the end of the pipeline. So how can we, even before starting the research, how can we even guarantee that these will be the deliverables?
So it's also an appetite and an overall maybe attitude towards science, not just the inefficiencies or the bureaucracy that's maybe driving the numbers maybe low at the moment.
Correct, yes.
How much annual budget do we have for these types of research projects?
Okay, I'm not sure, but I mean, you look at the news, and the main funding agency for this kind of research in the Philippines is the Department of Science and Technology. If you follow the budget deliberation
check
process,
now, yeah. But go ahead.
You can look it up. So, so usually the Secretary of the DOST during the deliberations leading up to the General Appropriations Act, makes a pitch, and then eventually it has to be approved in Congress and Senate, and then finally signed into law. And over the years, sometimes this goes up, sometimes this goes down. I guess it depends on who the administration is at the moment.
Let me check. How much annual budget does the DOST have for scientific research project? Short answer, roughly 8 to 9 billion per year.
Okay.
Which is the main national pool for Philippine government, which given to the DOST to fund scientific research grant. So total DOST budget for 2025 was 28.8 billion. For 2026, it was 30.4 billion pesos, of course. And for grants through the GIA program, Grants in Aid program, This is the pool universities, research startups, and institutes applied to 8.8 to 8.9 billion for this year, for 2026. So, importance. DOST accounts for 47% of the Philippine government's total R&D spending. So the GIA fund is basically the largest single research funding source in the Philippines. So around 30% of DOST's budget is actually for research grants. I wonder, well, from your knowledge in the scientific community or science community, what were the latest breakthroughs in the research space?
I mean, there have been so many, and I think that they don't get enough attention.
Sure.
Right? And that's why I'm glad that this interview is also taking place, because it's an
Yeah.
opportunity actually to talk about some of these.
Sure. Yeah, please do.
So I don't know. I mean, for instance, I think what is a huge feat, and which I think deserves more public attention, is the fact that we are able to manufacture satellites in-house already. Right, so this was under this project was under the leadership of Dr. Joel Marciano, who was then a professor of engineering in UP, and then because of the success of the satellites, Diwata 1, Diwata 2, and the Maya satellites, so he was eventually the Philippine Space Agency was signed into law, and he was appointed to be its first head. He has since left that position because he went back to the University of the Philippines as the vice president for research, right? But then, for us to be able to produce our own satellites,
Where is it produced?
in the university, so it's all in-house
In UP?
in UP. Yes.
So in UP Diliman, somewhere there, somebody's making a satellite?
yes.
Oh, wow.
Then these were done in collaboration with Hokkaido University. This is my recollection of that project. It was done in collaboration with Hokkaido, and I think Tohoku as well in Japan, which houses JAXA, the Japan Space Agency, because eventually the satellites had to be sent over to Florida, where they would be launched into outer space. And, I remember when the first satellite was launched, there was a whole watch party organized in the Toyota GT Center of UP. So everyone could watch and join the countdown for the launch of the rocket into space. And, why even have these satellites? Well, because the country needs them, right?
Is it for the Philippines, the satellites?
Yes, it's for the Philippines, because we keep, year in, year out, we always have these floods. And it's like you'd think, right now we have this whole flood control project scandal, whatever, right? And it's like, don't we ever learn, right? And with technologies like satellites, basically they provide topographical maps which tell you where the floods are going to happen, where the water is going to flow, which communities need to be evacuated as soon as possible.
Ito ba yung NOAA? Or iba pa?
NOAA is a separate thing.
Okay.
Right? So NOAA is also, when was this? Maybe 10 or 15 years ago, there really was a big investment on disaster risk management, DRM, so the disaster risk reduction and management. So Project NOAA was part of that effort as well, where Dr. Mahar Lagmay installed satellite dishes, radars all over the country, precisely to achieve the same end. To monitor the vulnerable areas. How can we transmit to the LGUs information as fast as possible that they need to evacuate their constituents, where can they be placed? But the information from all of this, it goes beyond flooding. So for instance, I remember attending a symposium where the ones presenting were from the LGU of Cebu province, and they said that they had used the information because now that they knew, they had the topographical understanding of their immediate environment, they used the information to be able to advise farmers on what to plant and where, right? So instead of just, doing random kaingin and burning whatever and just planting whatever. So now the LGU was in a position to advise the farmers.
To maximize yield.
Correct,
Crop
yes.
yield. Yeah, I was having a chat with Telo Asilo. He's a coffee entrepreneur. Does a lot of social entrepreneurship working with farming communities. And he did say through a USDA grant, he was able to do some agri-tech projects, which involved having some satellite tracking in terms of moisture and the conditions of the general soil and I don't know, maybe what do you call it? The
Altitude, maybe temperature
checks, which helps the farmers track and improve the yield. So maybe something similar.
Correct. Yes.
Okay. And when it comes to these types of innovations, you mentioned that. Well, now we know it's about 30%. Anything that, in terms of focus areas, the Philippines should focus on?
Oh gosh, there's so much.
Yeah.
This country has so much room for development, but then
if you had it your way, what are the 3 areas of development?
Well, okay, maybe not
research.
so much my way, but one thing which I think does deserve attention, because friends in the Marine Science Institute and in the National Academy of Science and Technology have been pushing for it, is to build the blue economy in the Philippines.
What's the blue economy?
We have over 7,100 plus islands, so much coastline. We should be making so much money from fish, ocean-derived products. And yet you look at among the most disadvantaged in Philippine society are the fishermen. It's right versus Singapore, for instance, who a tiny nation state, and they make so much money from chili crab. Right? So, the Philippines should be able to come up with something similar, right? Given that we have so much access to tuna, to sardines, to whatever, to shrimp, right? So, and no one is talking about it, right? So everyone is always talking about rice. We're always importing rice, more rice. It's like, but actually, the country can become wealthy if we push the blue economy.
Okay. And science can definitely help with that.
Yes.
Okay. Well, we got to take a short break, and then let's continue the chat after that.
Sure.
Right. So, Aaron, you were recognized as an outstanding young scientist in the Philippines. But what exactly does it take to be considered a scientist?
All right. Okay, I think really where all of this formally begins is when a person is trained up to the PhD level, right? So, I remember some decades ago when I was thinking of getting a PhD in, chemistry. The prevailing mentality then at the time, thankfully things have changed a bit now, but it seemed to me that the prevailing mentality at the time was that a person gets a PhD only at the end of a long academic career, as if the PhD is like some culmination of all of their whatever discoveries at the end of their lives. When actually the reality is the PhD is the first license to participate truly in academia. So when I left to do my PhD at the age of 20. How old was I then? At the age of 25, I arrived in the lab in the University of Manchester, and I discovered that I was the oldest PhD student there, because everyone else, all the other PhD students, were all maybe 21 or 22 years old.
Okay.
And, because the way all of this works is that the PhD is not just like a fancy title that you get at the end of your name. What it is that it's a sort of stamp, like a certification, which says that you have been trained in a particular skill set. And well, not just like manual skills, but also a particular way of thinking, right? So normally a PhD degree lasts what 4, 5, 6 years. If you go to the first world, where you have great access to instruments, great access to chemicals, great access to whatever. No? So, but yeah, I mean, these days. For a person to bag a good faculty position, particularly in the first world and increasingly even more so here now in the Philippines, you need at least a PhD and probably 1 or 2 postdoctoral fellowships under your belt. So, like, okay, for instance, in my case, I had made it like a target that I have to finish my PhD before I hit the age of 30. And thankfully, that's how things worked out. So I started at age 25, and then I finished at age 29. And then, but then right after that, one of the things that you realize when you do a PhD is that, well, you may have answered a certain set of questions and learned a certain set of skills, but there's always more to ask and there's always more to learn. And so, the motivation for then proceeding to do go on a postdoctoral fellowship is, well, it can be 2 things. It's either to increase your skill set in the current field that you're working in, or to go into something else, right? So that your initial knowledge and skill set expands into this new thing. So okay, for instance, in my case, my own PhD was all about synthetic inorganic chemistry. So synthesizing inorganic complexes with, well, the suggestion with the hope that these molecules that I was making could later on be used in the context of medical diagnosis. Since it's a university lab and it's PhD level work and everything was pretty much proof of principle, of course, at the end of that, the question in my mind was, so I've spent all of these 4 years doing this kind of chemistry. Can I actually apply it in the clinical setting? That's the reason why I applied, and thankfully I got into the U.S. National Institutes of Health. Because it's, the US NIH is basically, that federal agency of the US government, which precisely tries to develop new therapies, new whatever, to health. And so I spent then a postdoctoral fellowship at the US NIH because I wanted to apply the knowledge that I had learned over the course of my PhD and to see if I could really apply it into this translational laboratory clinical setting. Right. So, but then.
So, do you think to be a scientist requires at least a minimum PhD?
Today, yes. Right. Because, it's unfortunate that, I look at the news and I see stories about how since the PhD degree is being used as a metric for hiring and promotion, I'm seeing that there are cases where there are some schools who seem to be just handing out the degrees left and right because people are willing to pay for the label, right? But then it's not about the label, right? It's about having trained in specific high-level skill set and having the formament is having the mental framework to be able to answer these kinds of, to ask these questions and to be able to answer them.
If I could maybe ask, I mean, just a few weeks back, I was speaking to Mark, who invented an adhesive from, pili resin, right? Which is a patented technology. He doesn't have a PhD though. But to me, he seems a bit more like a scientist than maybe a PhD candidate or PhD who does not involve herself in research, right? So how do we marry that framework or maybe that notion that to be a scientist, maybe a PhD is
Well,
required?
okay. Really, where the PhD, the space where the PhD occupies is really the question of higher level questions, not so much the application, right? So normally, when you develop a huge body of knowledge, I mean, okay, certain aspects can be applied, but then the rest of it is really just knowledge. This is, I think, okay. Earlier I mentioned this thing of the risk, right? That's why it's. I mean, the amount of funding that is available for research really depends on the amount of risk a funding agency is willing to take on. So, like out of 1,000 projects, maybe one will work, right? So for instance, with the studies that we've been doing on peptide chemistry and neuroactivity, bioactivity, we've actually made so many peptides. We've optimized their synthesis in so many different ways. There's so much information, and yet only a tiny bit of it actually reaches the publication stage. And from the publication stage, only a tiny bit of it actually ends up being commercialized or going into, finds an actual application. So you see what I mean? There's, okay. In the 18th century, the King of England established the Royal Society because in the UK, because precisely the monarch realized that by providing royal support for people to engage in this kind of science, to engage in what was then referred to as natural philosophy, it meant that, there would be a benefit to the realm.
Okay.
Because eventually, at one point, one of these natural philosophers might stumble across, because of their own curiosity of looking at observing natural phenomena, they might suddenly come across something which will benefit the citizens of the nation. Maybe, a cure to a disease, or maybe a better way, electricity, or a better way of whatever, doing something, right? So, but that's a risk that, someone has to take. A nation, a monarch, the government has to take, or a venture capitalist.
Yeah, and I was just researching in terms of the ratios because we've established that annually the budget is 9 billion pesos, right? But the total national budget is 6.3 trillion pesos. So actually it is 0.14% of the Philippine national budget. Research.
Okay.
Research. So that's less than 1%. So let's ask, how much does it compare to Southeast Asian counterparts and first world countries? Yeah. So I think you mentioned a great point. Like in terms of risk and reward, a country has to maybe bank on research and these new scientific breakthroughs, that X% of it will have a bigger impact to the rest of the country and bring in maybe new jobs, new economies when it comes to the science. Well, what were the maybe biggest scientific breakthroughs for the Philippines which has actually done that?
Oh,
I don't know if you're familiar.
what do you mean? Translated into like a commercial product, or just impact
Maybe
on
both.
the Philippines?
Both.
No, okay. I mean, one which I can think of, which I feel has had a tremendous impact on Philippine society, is the work of my former boss. Her name is Dr. Rodora Asansa. She used to be she was a professor of the Marine Science Institute, and she became the dean of the College of Science for several terms, and then eventually she became my boss when she was put in charge of the international office of the University of the Philippines system, and I was her deputy director. Later on, after her retirement, she became the president of the National Academy of Science and Technology. But anyway, what's her claim to fame? Well, she had studied the complete life cycle of the red tide. And I remember how, as a child, the red tide
Nasa
would
news
always...
yan lagi dati, di ba? Uy, red tide, don't eat fish.
Exactly,
Don't
di ba?
eat
Bawal ang
seafood.
tahong,
Oo,
malalason
bawal ang
ka
tahong.
dyan, yes.
Tama. Pero may
Right?
tama ba? May namatay kasi dati, di ba?
Yes,
Tama ba?
yes.
Because of red tide.
Because of the red tide, especially in the 90s, it kept coming out in the
Yeah.
newspapers,
So,
right?
well, we do have Gen Z audience and baka younger millennial audiences listening to the podcast. So what exactly is the red tide?
Well, basically, the red tide is referred to as one of these harmful algal blooms. I mean, I'm not an expert in the red tide, no? So it's, it's well, basically, you have this the harmful algal blooms, which eventually the shellfish ingest, and together with their toxins. And so the first persons to be exposed to the toxins of the harmful algal blooms were the fishermen themselves, right? So because
Ano
they were-
nangyari sa kanila?
well, I mean, okay, the exact disease, I don't have the details, but eventually with the toxins, people would die, right?
They died.
And so, what Dr. Azanza did was, well, to if you want to find a solution to this problem, which was really a problem that was affecting Philippine society and its fishermen, well, first of all, you have to understand the organism, right? What is the organism that causes it? How does it work? Why is the red tide a seasonal thing? What triggers, what environmental events trigger the harmful algal bloom, so on and so forth. But what really impressed me with what Dr. Asansa did was that beyond just staying at the level of, let's study the organism, let's see, she went on to coordinate with the DNR, with the, the environment, the Bureau of Fisheries, with the, with the Coast Guard, so she ended up coordinating, with all of the agencies and on, helping the fishermen avoid the red tide, have all of these policies put into place. And now here we are in the year 2026. We barely hear about it.
Oh,
And
well, actually, wala na.
Exactly.
Actually, if you talk about red tide, maybe nobody younger than 35 will probably remember hearing about it.
Right? Because it all began with scientific research.
Yeah, and because of that, so what did she find out exactly? And then how did that affect our way of doing things in maybe the fisheries?
Oh, well, exactly, I don't know. I mean, we'll have to read through decades of this research. But
essentially, she figured out what causes it.
Yes. And therefore, how to manage the situation.
Okay. I was using AI to look at the conversation we had on R&D spending ratio to GDP. So Philippines, well, a while ago it was 0.14%, right? Or maybe let's put it on the high side, 0.2. Indonesia is also 0.2, Vietnam 0.5, Thailand is 1.1%. So they spend 5 times more than the Philippines when it comes to research. Malaysia 1 to 1.3%. Singapore is the biggest at 2.2 to 2.5%. Of course, there's also Singapore's GDP is also, I think, much bigger than us, if I'm not mistaken. But let me double check that.
Well, I think a more useful metric is to look at the number of researchers per million population, right? So some years ago, I had published an article which came out in the Manila Bulletin, where I basically talked about, I did a comparison of the of data published by the World Bank on, and basically just boiled it all down to number of researchers per million population. And, what the numbers had shown is that while first world countries, the US, UK, Singapore included, had around 5,000 researchers per million population, the Philippines only had something like 100. And based on, I did a quick search, just before this interview, and seems the numbers haven't really changed significantly. I mean, we're still not on the level of Singapore. We're still not anywhere close to. In fact, our near neighbors, like Vietnam, is definitely on the rise. I mean, they're spending on science research, and I'm so impressed with the Vietnamese EV taxis, which we're now seeing in greater numbers here in the Philippines. So,
Well, they are. Well, it says here 0.5%. So they're spending twice as much in R&D than in the Philippines. And then in the developed or innovation leaders, US is 3.4%. Germany 3.1, Japan 3.3. South Korea is actually the highest at 4.8 to 5%.
4.8. Okay. How about Israel?
I haven't. Well, they didn't pop up here. China's 2.4%, but there's
Okay.
also probably a factor of the nominator and denominator because
Yes.
the GDP is too big. So,
Okay.
but yeah, to your point, how many was that? 100 to 5,000 people are scientists or researchers?
Researchers per million population.
And then the average, or maybe the more advanced, have how many?
No, yeah, the advanced are around 5,000. And then Philippines is 100
Okay. Per million.
per million population.
Okay. So,
So you see, I mean, so then the question then becomes, so why are there so few?
Yeah.
Right? My opinion is, number one, it's difficult to be a researcher in the Philippines because your research work is always tied to a project. And the way the funding agencies, fund projects is, it's always on the three. Okay, number one, it takes 2 years to get approval, and after and once the project is approved, usually project lasts for 3 years, and then before that ends, you have to have a constant. If you want to keep your manpower, people whom you have trained in a particular skill set, you have to keep applying for projects which last for 3 years, knowing that it takes 2 years to get
to
an
apply.
approval.
Okay.
Right? So, and there's no guarantee that you're going to get approval. So how is any of this stable?
So it's just too high risk for someone
It's
to
very
venture
high
into
risk.
it.
Yes.
And
so,
and for all you know, your 2 years could go to waste
exactly.
if it doesn't get approved.
So then you lose all the people, and then let's say you try, maybe you try in the next application round, and then here we go, another 2 years. Then you then have money, and let's say it does get approved. You then have to hire a new set of people whom you have to train again from scratch.
And I think versus, let's say, first world countries where, let's say it takes 2 years. Fine, because of the social security that you're provided, right? But for countries like the Philippines where, 2 years you're not sure of what's gonna happen,
Yes.
if you actually will have a job to, or you'll actually have something to work on. It's a bit too high risk.
And this is why precisely we have brain drain, right? So then many aspiring Filipino scientists just decide to develop their scientific careers elsewhere. And you look at all these. You look at the U.S., you look at Europe, you look at Australia. I mean, you have universities with famous Filipino professors, famous Filipino researchers, and they were able to flourish and grow their careers abroad. And so many people ask the question, like, why couldn't they have done the same here in the Philippines?
Well, for sure they're getting paid 10 times, 100 times
that's
more.
another thing, right? So compensation.
Yeah, don't we have any government programs to regain the brain?
Okay, yes,
That's
there
been
is
drained.
one. Yes, there is one by the DOST called the Balik Scientist Program.
Okay.
It's been around now for some time, but then I remember, when I was still with the International Office of UP, we were running a program called the Balik PhD Program, which was basically a faculty recruitment program to offer, because the fact is, many Filipinos are abroad simply because circumstances, for
Ang
them
hirap
to
ng
develop
buhay dito eh.
Exactly.
Oo.
So we wanted to give them a way to come back, right? So we crafted the Balik PhD program. This was the brainchild of the former VP for Academic Affairs of UP, Dr. Gisela Concepcion. And the idea was to offer these Filipino scientists who were considering coming back to the Philippines, to give them a relocation package, to give them startup research funds so that they can, set up shop here in the Philippines, and then once they get going, then they can go on to, because the reality is there are many Filipino scientists based abroad who want to help the Philippines, right? So the Balik PhD program then had some success, and so I remember having to testify in the Senate at the time during that. Because it was then Senator Bam Aquino who was pushing for this new bill for the Balik Scientist Act, and then
Did it become a law?
yes, it was signed into law.
Okay.
This was back in, let me see, during his first term as senator. So because now Senator Bam Aquino is back again, right? So, and he's again pushing for education. So yes, it was signed into law, and so thankfully through the Balik Scientist Act, the Balik Scientist program now has all sorts of different outfits. Like there's BSP short term, BSP long term, and so it's now thankfully an avenue for Filipino scientists who are based abroad to come to the Philippines, maybe spend 6 months, maybe spend I don't know, a sabbatical year, maybe 1 year, like helping out with universities in the Philippines to get their research up and going. So, but again. In the first place, Filipino scientists would not have had to go to some other country if the setup here was better, right? So in the same way that, for instance, I mean, with respect to like nearest neighbors, I'm really impressed with the way Taiwan set up the Academia Sinica, which is like their national research agency. And I'm hoping that in time, I'm from the Institute of Chemistry. For many years, the Institute of Chemistry has had collaborations with the scientists at Academia Sinica, and I'm hoping that one day something like the Academia Sinica or something to the level of Academia Sinica could be set up here in the Philippines.
And what exactly is Academica Sinica's objectives and maybe contribution to Taiwan?
Well, it's basically their national research agency.
Okay.
Just like
So finding things out for the sake of it, and hopefully whatever you find out helps the country.
I mean, the U.S. has NSF and the NIH, and what do you call that? The UK has its research councils. Japan has RIKEN. Taiwan has Sinica. The one in Australia is it'll come back.
Tayo
to me.
wala pa. Parang it's still at the university level. And
Well-
then it's just supported by the DOST.
Well, the DOST itself has been slowly expanding its own in-house institutes. For example, one that I see often now in the news is the Institute for Textile Research. Because again, it's an area that the Philippines, with its access to all sorts of different plant fibers, I mean,
And culturally, I think it's been
and culturally, yes, as well.
hundreds and hundreds of years being done by our ancestors. I think.
Exactly.
Yeah.
So there's already like a basis for it, right? So it's just a matter now of leveling up, doing the research, and then expanding, to the application.
Yeah.
So
different tribes have been doing different types of textile weaving and all that, right?
correct. Yes. So I think the most stellar research institute of under the DOST is the Philippine Nuclear Research Institute. So I don't know if you will be inviting Dr. Kaloy Arcilia to the show.
Yeah, I already contacted him.
Okay.
Just couldn't land on a date yet.
All
but
right.
I'm looking forward to it. So Doc Kaloy, looking forward.
Well, he just recently retired, so now
I heard. Now he's back in UP, right?
Yeah, well, he basically retired from government service in general. So, but I hope he stays on to act as a consultant with the PNRI, just to so that he could see through all the amazing things that he managed to implement during his tenure at the Philippine Nuclear Research Institute. I mean. Okay, PNRI has consistently been the most scientifically productive among the in-house institutes of the Department of Science and Technology. And again, this is something which I feel that Philippine society in general does not appreciate enough. Right? So, because whenever people hear nuclear, they immediately think, oh, nuclear bomb, and then Chernobyl or whatever, right? So, when actually, I mean, there's so many applications, so many useful applications to nuclear science. And again, it's a question of getting the information out, educating people that actually, I mean, you look at many first world nations, they use nuclear science in so many aspects of their lives.
What other aspects, if you don't mind? Even just quick
okay, first energy. Right?
energy, for sure.
Right?
Yeah.
So you need, as Dr. Arcelia himself would often say, I mean, you need really a stable base of, in this entire energy mix, you really need a stable base of energy, which is something which nuclear can provide.
And you need to diversify. Right?
Yes.
Okay.
I mean, the problem with solar is that you don't have sun 24 hours of the day, right? The thing with wind is that you don't have wind all the time.
Yeah.
So, but, with a tiny amount of nuclear material, you have a constant source of energy.
Interesting.
So that's one. So energy. And if the economy is to grow, well, you're going to need
More energy.
more energy.
Yeah.
Right? So
Especially with all the AI data centers.
or the current oil crisis,
That's
because
right.
we're so dependent on oil, then everyone is like, what are we going to do? If we had shifted to nuclear a long time ago, and if everything was just run with electricity, if power produced from nuclear energy, well, we would be shielded from the effects of this oil crisis.
So if you were talking to your younger self, or maybe there's someone out there, an aspiring scientist, Filipino scientist, what would you tell that young scientist in terms of how to navigate through his scientific career?
Get a PhD as soon as possible.
Yeah.
Yes. Step one, do not delay. Get a PhD as soon as possible. As young as possible.
And abroad, maybe? Ideally?
Currently, yes. Currently, that's the way to do it. Yes.
You've traveled all around, of course, for your academic pursuits. What do you notice as maybe hot topics or key areas, fields where there's a lot of scholarships going around for people of science?
That's a difficult question to answer because there are just so many. Chemistry alone, there's so many things to look into. And so if you're precisely the personality who is just curious, I mean, who just likes discovering things, because there's a certain high when you make a discovery, right? So, I mean, there's
Anything. As long as it's free and it's in a great country, why not?
I mean, there's just so many things. And I don't know. I guess this is the reason why, with respect to career planning, it might be something, I mean, each person has to think about, okay, how do I align my curiosity, my interests with whatever needs there are in society, which, I can eventually sort of like insert myself and make a contribution. But yeah, I mean, for instance, what I know is that when the Nobel Prize was given to nanoparticles, suddenly left and right, so many people now want to do nanoparticle science. And I don't know. Sometimes I feel nanoparticles is just like a marketing term, but anyway, but that's just me. Because as a chemist, I really prefer molecular science, right? I don't like big things. Nanoparticles for me are gigantic. No? So even though the name makes it sound like they're very small, but for me, they're gigantic. So because I'm a molecular scientist and I look down to to molecules and what they can and how the molecules behave. So I don't know. I mean, over the years, I have advised grad students who are interested in pursuing their PhDs abroad, and you see that there are different personalities. Like there are some who prefer computational sciences more. There are others who prefer research that's more field work. There are others who prefer work that's more laboratory based. There are some who are excellent at instrumentation. Right? I mean, they be confronted with this high-tech piece of equipment, but they're fearless with, they're not, usually people are afraid, if I work with this, I might break it and, yari ako and all that. But no, there's some people who are just so good with their hands and they're not afraid to start working with high-tech pieces of equipment and they can even customize the equipment to answer the kinds of questions that they want. So I guess a part of it is personality-based.
Is there money in science in the Philippines?
Oh gosh, it's better than it was. I think when I came back 15 years ago. So in fact, when you look at the age demographic of the professors, at least in my department in UP. Well, there was a time when you had the most senior people, but that age group is currently retiring or has retired already. Then there was an age gap of around 10 years or 10, 15 years. Basically, that generation all decided to build their careers abroad. Then you have my generation, mid-40s, and then up to late 30s. This was the generation of Filipino scientists who decided to come back during the Pinoy administration because things were looking favorable. And then beyond that, we see another gap. So it seems that there seems to be a correlation with the government administration and the desire to build a scientific career here in the Philippines, right? So if ever, regarding the question of money, certainly there's a greater awareness now and better processing of research grants, even though precisely it takes 2 years. There's still room for improvement. But compared to 20 years ago, I mean, it
Malayo
was,
na din.
yes. So we've come a long way.
Okay. Yeah, because of course, the Philippines being still a developing country, a lot of, our population is still essentially experiencing a certain level of poverty, right? Parang, syempre, yung natural inclination ng tao because of, basic human survival or basically because they need to support, their family, diba?
Yes.
Is parang find something that is lucrative at the onset, and even people in the scientific fields, diba? They postpone their doctorates because they need to provide right away. And maybe that also limits, the level of maybe scientific thinking or culture in the country. Diba?
Yeah, again, it's related to what I mentioned earlier about the way science is working in the Philippines at the moment is that everything is primarily project-based. Once a project is over, and there isn't another project that will, reabsorb the accomplishments of the first, then you lose everything. I mean, you lose most importantly, you lose the manpower whom you've spent 3 years training, right? So how can you guarantee a sustainable, effort to come up with a solution if you have to keep retraining and retraining and retraining people every time?
Yeah, and I can imagine. Well, apart from the Balik Scientist program, meron bang ibang nangyayari now from a national policy perspective to push for more science?
Not that I know of.
Not that you know of. Okay. And maybe if have you ever thought of any programs, or like maybe if you had it your way to lobby something in Congress or in Senate in terms of what to do for science What would the first thing be?
I think it's to support the in-house research, because so I mentioned that DOST actually has its like in-house research institutes. Those should be expanded, and the variety of institutes should be increased, right? Because again, if the funding comes from the DOST, if it's in-house within DOST, then it's money which comes from the General Appropriations
Yes.
Act. So the careers in DOST truly are careers. You get a job, you're in a job. It's not, oh, here's a 3-year project, it ends, and then that's the end of it, right? Go do something else. So this is the reason precisely why the PNRI has been so successful. Because, you can develop whole careers as a scientist in the Philippine Nuclear Research Institute. So, yes, they have some projects, special projects that are going on, but they also have stable stable projects. Like for instance, one thing which many people don't know is that irradiation of produce actually prolongs their shelf life. And so there are actually fruit exporters who have their fruits irradiated at the PNRI prior to shipping out. Yes.
Kala ko pag radiation bad yun. Hindi pala.
So, and this is something which is not just done by PNRI. This is done by first world countries as well, right? So, or for example, the irradiation, using radiation to sterilize medical equipment. So a lot of our medical equipment precisely is guaranteed bacteria-free.
Yan ba yung UV? Back to zero.
Even more powerful than UV. This is
Okay.
nuclear.
Nuclear. Okay. Yeah. So essentially, what I'm getting is, more funding so that the DOST can diversify and make a longer career plan for scientists, de-risking them of that, that project-based feeling where you're not certain what your career will look like X years from now.
Exactly.
Okay.
Yes.
Okay,
So
that's good.
more PNRIs in the country.
Yeah. Oh, great. Well, I think we got to wrap up in a bit,
Okay.
Dr. Aaron. But maybe any last promotions or maybe advocacies that you want to talk about?
Yeah. I think one idea that I would like to share is if we consider, if our definition of culture is the sum collection of activities, human activities which, give meaning or value to a society, then, I think science has been the biggest contributor to human culture. I mean, normally when people think of culture, they think of whatever, literature or, I don't know, paintings, statue art, sculpture, art, architecture. No one mentions, actually, science. If you are a truly cultured person, you have to be scientifically literate. So we look at from the beginning of the human race, the discovery of fire, the discovery of the wheel. Later on, there have been so many discoveries, scientific discoveries, which really changed the path of the human race and, allowed it to flourish, gave it meaning, gave it value.
Well, all the industrial revolutions are actually from scientific breakthroughs.
Yes.
Right?
Right. So all of the economic miracles in countries are due to the scientific innovations happening in those countries. Right. So when people, when someone says, "Oh, here's a cultured person, knows literature, painting, whatever," but then doesn't know anything about science, I said, this person isn't cultured. Right. So to be a truly cultured person, a person has to be scientifically literate as well.
Yeah. Well, hopefully we do experience those scientific breakthroughs that yield to some form of industrial revolution in the country, thereby, improving the general human condition here in the country, right? Given where we are at the moment. But
And also, science is fun. I don't know, people tend to think, science pang matalino lang yan, or dapat nerd ka. No. Science is fun.
well, being a nerd is fun. Depends though. And yeah, but science is usually a tough subject for most. I wonder like kasi sa grade school, yung mga well, we have Pisay naman, 'di ba? For
high school, yes.
Yeah. Pero sa grade school, parang depende din sa school siguro na pupuntahan mo. Pero 'di ba, usually ang project mo lang diyan, yung baking soda pati vinegar na may volcano eh, 'di ba?
Yes. This is the challenge of the DepEd. Right? So, I mean, as a UP professor, what I've been seeing is that
Pati solar system.
yeah, I mean, I see students
Mga
struggling
planetang nasa barbecue stick, mga
with
ganun.
styrofoam ball.
Styrofoam
and,
balls.
so it's like I see students struggling with concepts which had, if it were, which concepts which would have been taught at a high school level if it was a first world nation, right? And we're seeing that college, in other words, they're not being taught the high school level. So, I mean, I don't know if you've been following the EdCom 2 reports, right? But so you can look it up. But really clearly, I'm so thankful for the work of Dr. Carol Marquis, for precisely studying the education system, all the work of EdCom 2, and highlighting, okay, these are the areas which need to be improved. And I hope that, that the reforms are put into place.
Good. Well, this has been an enlightening chat, Aaron, and I had fun. It's always good to chat with you, especially about science.
It was fun for me as well.
Yeah, and maybe, when we have these breakthroughs or when something pops up with your new research, let's have you on again and
Sure.
Yeah. But I haven't seen any recent news in the science space. Or maybe I'm just not into the news lately. But when there is, let's do this again and have another good chat.
Yes, will do.
Good. Well, that's it for today, guys. So thank you for listening.
Okay.
Thank you. That was good.